Hello. In the last session, we saw how the base model of a large language model is created. The base model, also known as the pre-trained model. And the pre-trained model actually isn't very useful. You can't chat with it. So in this session, we're going to see how a large language model is made so that you can chat with it. Um, so you may have come across this. Meta, the Facebook company, released a large language model, the base model called Llama 3.1. The base model is actually the expensive part of creating a large language model. It literally costs hundreds of millions of dollars to create these big large language model base models. And by releasing the base model, what Meta have done is meant that people can use it for training the next stage, which isn't as expensive. It's still a really big thing to do, but you can use the base model and train it with the kind of methods that we're going to show now. So all of my demonstrations are live. So because of the way large language models work, we're never sure exactly what's going to happen. But here we're looking at the Llama 3.1 base model, right? So this hasn't been trained to chat. So if we ask it a chat type question, what's going to happen? It's what is the capital of France? It's responded, what is the currency of France? How old is France? So it's responded with more questions, right? Let's just try it again. What is the capital of France? A radon, B neon. So it's come up with a like a multiple choice response. It seems to have got confused with a particular element that has a similar kind of name to France. But anyway, you can see this is just not the response that you would expect, and not a very useful response. And this is from the model that costs over $100 million. So that's curious, right? So how do we go from this to a large language model that you can chat with? I just want to do a quick refresher on how the base model works. So basically, text that you put in is converted to tokens, which are essentially numbers. Those go into the large language model. What comes back is a list of probabilities of the next token, and then it chooses the next token, not necessarily the most probable one, but they're weighted by those numbers that are returned. And so in this case, it's chosen 2. Today I am going 2. And then that whole string of numbers is fed back in again, and that is used to generate the next token. So it's this iterative process of putting everything that's come before back in again to get the next token. So we're going to look at 3 of the main methods used for training: supervised fine-tuning, reinforcement learning, and reinforcement learning from human feedback. These aren't all the methods that are used, but these are 3 of the big ones. So supervised fine-tuning, what is that? So that came from this paper from OpenAI in 2022. I've highlighted a little bit of it here. We collect a data set of labeler demonstrations of the desired model behavior, which we use to fine-tune GTP3 using supervised learning. So the data set of labeler demonstrations, a labeler is actually a person. And the demonstrations are demonstrations of chat. So in other words, a question and an answer, and a very large data set of those questions and answers. Here we have an example of one of those data sets. So you can see in this column, text, we've got a question, and the role is prompter. So that's the question coming from the user, and then an answer coming from the assistant. That's the large language model. And then we've got the same question put another way. Now explain it to a dog, and the answer from the assistant. So the thing you've got to keep in mind is that these are all written by humans, both the questions and the answers. And so very often the OpenAI and Anthropic and Meta employ specialists in their fields, and lots of them, to write these questions and answers. And there really are a lot. So this is one page of those kind of questions and answers, and you'll see we've got 845 pages like that in this particular data set, and in different languages as well. So that's one very large data set of questions and answers. This ultra chat is an even bigger one. I'm zooming in here, and you can see there's questions and answers on all kinds of different subjects. We can click on one of these dots, and then on the side here it should show the text, the question and the answer in that case. And with these really large data sets, one of the methods that's used is, now that we have large language models that can generate questions and answers, they're generated, and then human checkers will go in and make sure that the questions and answers look correct. So this is about training the AI in how to respond in that question and answer kind of way. So the people that are the labelers for this data, the people that actually write the questions and answers, get given a huge manual, like 100 pages or more long, which they have to read through, which tells them exactly how to respond. So this kind of gives the large language model the personality it gets. And that personality actually comes from humans doing this kind of activity of giving the large language models a huge amount of examples. So let's just do a refresher on tokens. So what is the capital of France? Each word in this case is made into a token, which is just a number. This is based on the frequency of series of letters in the training data. So in this case, the tokens are all words including spaces and things. But that's not necessarily the case. So with longer words, it's likely that they're split into multiple bits because there'll be a frequency associated with the different sequences of letters. So the reason I wanted to go over that is because now with this new type of training, we actually have new tokens that train the model in this question and answer kind of setup. So we have here user, what is the capital of France? And then we would have the assistant respond Paris. So that gets translated into a string with special tokens. Tokens telling you what kind of entity it is, first of all, in this case, the user, then a separator, then the question, ending that section. So there's these new tokens that go into the model. So when you type a question into something like ChatGTP, the appropriate tokens are put around your question when it's fed into the model, along with the bit that says that it's expecting an answer. So the training is essentially the same kind of thing, but just with these new tokens that are delimiting the kind of information in it. Now, reinforcement learning, how does that work? This is a paper from DeepSeek. They use some quite novel methods for training. This is a paper from the beginning of this year. Um, and in this case, the way you do it is, well, let's look at the demo first. If I have 5 oranges and give 3 to Bert and he gives 2 to Emma, how many does Bert have? So Bert has 1, right? Because he had 3 and he gave 2 away, so he has 1. And it's come up with the right answer. But because of the way that large language models work, where there's randomness involved, it'll come up with different answers or different ways to work out the answer each time you ask it. So you'll see it's come up with a slightly different method this time. It's come up still with the same correct answer. Let's just do it one more time. It's a fairly easy question in this case. And you can see it's a slightly different method again. So you do this, but with slightly harder questions than this, where the model may make a mistake, and you do it multiple times. And then when it gets it right, you basically increase the weights in the model for those tokens that contributed correctly. When it gets it wrong, you decrease them a little bit. So it's basically on asking a question multiple times and then rewarding the correct bits of the model when it responds correctly and reducing the weights when it answers incorrectly. So you basically do this with kind of maths type problems where there is only one correct answer, right? It couldn't work otherwise. So what do you do in the case where you want to teach it to get better at poetry or writing jokes or philosophy? It's a lot harder, basically. So this is called reinforcement learning from human feedback. And in this case, you might have a question like this. Tell me 5 jokes about giving a presentation on training large language models. Let's see what it comes up with. But if you think about jokes, for example, they're subjective, right? Different people will find different things funny. And it's really hard for us to kind of quantify how good a joke is, give it score out of 5 or whatever. It's a really difficult thing to do, and it's very difficult for poems and writing and all kinds of stuff to quantify that for normal people. So the way this works is, as here, you ask for 5 responses, and then the person training the model is able to kind of drag and drop them into some kind of order where it seems like, the top one is the best one and the bottom one is the worst one. And that's a little bit easier to do than give these things a kind of quantitative score. And this works to an extent. You can do it a little bit. You can do a few iterations of this kind of training, but it's not, the answer to this problem of how do you train models on this kind of subjective response. One of the problems is because this is all based just on statistics, and you've got 5 responses here. The model could respond with just 4 really bad jokes and 1 really good one, and it, in the way that it works, the one that's number 1 there is just the same as a number 1 where all of the jokes are good, right? So it's not a foolproof method of doing this, and you can only do it a little bit and just improve things a little bit. So that's how AIs are trained, and they still, even after all of this training, sometimes make mistakes, and in the next session we'll look at the kind of mistakes that large language models make and why they make them, and how they are developing ways to stop large language models saying stupid things, basically.